research, how they can help researcher, and what we can learn from them. Sampling plays a crucial role in research because it allows us to gather data efficiently without the need to survey an entire population. By using appropriate methods, we can ensure that our research results are reliable, accurate, and representative of the group we are studying. As a researcher, these methods help us determine who our survey respondents should be, ensuring that we collect relevant and meaningful data. Throughout our discussion, we will explore the difference between probability sampling and non-probability sampling, as well as the various types of each category. By understanding these concepts, the audience will gain insights into how researchers select their participants and why sampling is essential in conducting effective research.
Simple random sampling is a method of selecting a sample from a larger population, where every individual has an equal chance of being chosen. This technique ensures fairness and prevents bias, making sample truly representative of the entire population. For example, school wants to know if the students are satisfied with the cafeteria food. Instead of asking every student, they randomly select 100 students from the entire students' population to answer the survey.
Good day everyone, my name is Sofia Kim Salazar, and today I explain the types of probability sampling, which is stratified random sampling. Stratified random sampling is divided into distinct subgroups called strata, and I give example of this. In a survey about university students, you might want to ensure that each major, engineering, arts, and business, is well represented in the sample. You divide the students' population by major. Randomly select students from each major to form your overall sample.
Hello everyone, I am going to explain what is cluster sampling. So, cluster sampling is a probability sampling techniques where you divide a population into groups called clusters, and then you are going to randomly pick an entire clusters to be part of your sample. So, I am going to explain what are the step-by-steps of cluster sampling. So, number 1. Define the population. Clearly identify the target population you want to study. Number 2. Divide the population into clusters. Make groups of people that are diverse within each group, but the group are similar to each other. Number 3. Randomly select clusters. Use a random sampling method to choose the clusters to be included in your sample. And lastly, collect the data from the sample. Collect the data from every person in the chosen group, or pick some people at random from each group to get information from. So we are going to compare cluster sampling and stratified sampling. So imagine you want to survey some of the students about their favorite subject. So, first is cluster sampling. Cluster sampling is you randomly pick a few classrooms and survey all the students to those classrooms. Stratified sampling is you divide students by their grade level, and then you randomly pick some students from each grade level to survey. So the stratified sampling one have strata and stratum, and I use strata to my example because I am going to divide the grade level. So that's the comparison of these two.
Hey everyone, welcome. Today, we're going to discuss the systematic sampling. So what is systematic sampling? Systematic sampling is a type of probability sampling where we select members of population at regular intervals. Think of like it this. You got a long line of people and you pick every fifth person. That fifth person is our interval. We call it N. What are the steps in the systematic sampling? First, we need a complete list of everyone in the population we're studying. This is our sampling frame. And the second step, we need to decide how many people we want in our sample. And the third step, we divide the total population sized by the desired sample size. This gives us an hour sampling interval. And the fourth step, we don't just start at the beginning. We randomly pick a number between 1 and n to be our starting point, and this helps us to prevent bias. And the last step, we select every n. From that starting point, we select every n person on the list. But like everything, there are some downsides of the method, and the downsides of systematic sampling is pattern can mess things up. If there's a repeating pattern in our population that match our interval, we might get as sample. Imagine if something houses on the street, if every 10th house in a corner house and our interval is 10, we only get the corner houses. And then it can be manipulated. Someone could choose a specific interval to get result they want, which isn't good for science. And we need a complete list. We need that perfect list of everyone in the population to start with. If we don't have that, this method won't work. Okay, so what is the good thing about the systematic sampling? It's easy, it's super simple to understand and use, and much easier than some other methods. And it's efficient, it's faster and cheaper than some other methods, especially with a large population.
Hi, I'm Jangao Althea and Tulay, and I'll be introducing the convenience sampling. The other type of sampling is non-probability sampling and non-probability sampling. Only few people can be selected, and it relies on convenience and judgment. Convenience sampling is a sampling technique where the participants are chosen because they are easily accessible, convenient to the study. For example, you are conducting a research and need someone who is easy and convenient to participate. The sample may not accurately represent the larger population, as participants are selected based on convenience rather than random selection. Convenience sampling can be useful in pilot studies to test research instruments, procedures, or hypotheses before conducting a larger and more representative study.
Good day everyone, I am Marylin A. Cadag. Today I'm going to explain what is volunteer sampling. Volunteer sampling is a non-probability sampling method where people choose to participate, and it's also known as self-selected. For example, the grade 12 student, he conducted research questions for their interview. A student came to approach them, and Mila is willingly to contribute their thoughts and experiences. She actually voluntarily to them answered the question made by the grade 12 student. The typical application of volunteer sampling is like online survey or online poll. Voluntary bias, also called self-selection bias, in which participants choose to volunteer if they want.
Quota sampling is a method where researchers divided a population into subgroups and then select a set numbers of participants from each subgroup. This ensures the sample reflects the population diversity. Quotas are determined by dividing the population into subgroups based on specific characteristics like age, gender, or income. The proportion of each subgroup in the sample matches its proportion in the overall population, ensuring diversity and representation. The similarities of quota sampling and stratified sampling aim to ensure that different subgroups within a population are represented in a sample, but they do so in distinct ways. In the differences, quota sampling selects individuals to meet specific quotas for subgroup of the leading of two selection biases, while stratified sampling divides the population into strata and randomly select individuals from each, reducing biases and improving representativeness. Quota sampling is quicker and more flexible, whereas stratified sampling is more accurate and precise.
Now, let's proceed to snowball sampling technique. Snowball sampling is a non-probability sampling wherein existing study subjects recruit future participants. This method relies on social networks to gather data, making it particularly useful for reaching specific or hard-to-reach populations. Here in snowball sampling, the process starts with a small group of initial participants, who are often referred to as seeds, who then refer others, who in turn refer more, creating a snowball effect as the sample grows. Now, what are its applications on hard-to-reach populations? Number 1, it has access to hidden populations as it allows researchers to reach populations that are difficult to identify, such as drug users or people with rare conditions. Number 2, large networks. As more participants are recruited through referrals, the sample grows, which is especially valuable in studying population. However, while snowball sampling is valuable for these purposes, it can introduce biases, like due to lack of diversity in the sample, since participants are recruiting others from within only on their social circles. Now, I will provide some examples and challenges of using this method. Example number 1. If ever the study is about rare disease like a certain type of cancer, researchers might begin with a few patients who have been diagnosed. These patients can then refer others they know who are also living with the same condition, helping the researcher form a larger sample despite the rarity of the disease. Now, example number 2. A researcher is interested in understanding the social dynamics in a particular subculture, like gamers might begin by interviewing a few known individuals within gaming communities. These participants might then connect the researcher with others in the community, helping the researcher explore the subculture more deeply. Now, what are the challenges of using this method? Number 1, sampling bias. One of the main risks in snowball sampling is the potential for bias, since participants recruit others from their social networks, so the sample may not represent the broader population. Number 2, ethical concerns. The challenge of this is the confidentiality and privacy can become a significant issue, especially when dealing with sensitive population. The process of participants referring others might reveal information about participants, identities, or behaviors to people outside the study group. Last, number 3, is dependence on initial seed participants. The success of snowball sampling depends heavily on the initial participants chosen. If the seeds are not well connected or are hesitant to engage others, the snowball effect may be weak, resulting in a small or non-representative sample. While snowball sampling is a powerful tool for reaching hidden populations, it comes with several challenges, especially concerning biases and ethics. Researchers need to carefully design and manage snowball sampling studies, ensuring they address these challenges to maintain the integrity of their actual research and ensure ethical practices.
All random sampling. Every member of the population has an equal chance of being selected. Ensures that the sample is unbiased. Random selection can be done using a lottery or random number generator. Systematic sampling. Every member of the population is selected after choosing a random starting point. Can be more efficient than simple random sampling when working with large population. Risk of bias if there is an underlying pattern in the population. Stratified sampling. Population is divided into distinct subgroups, strata, based on a shared characteristics. Random samples are taken from each subgroup to ensure representation, reduces variability within the sample and increase precision. Cluster sampling. Population is divided into clusters of 10 based on geographical or organizational boundaries. Entire clusters are randomly selected, and all members of the chosen clusters are surveyed. Convenience sampling. Samples are chosen based on ease of access, quick and cost-effective but prone to significant bias. Snowball sampling, often used in hard-to-reach or hidden populations. Existing participants refer new participants to the study and create a biased sample as it relies on networks. Quota sampling ensures specific subgroups are represented in the sample based on characteristics like age, gender, etc. Participants are chosen non-randomly, often based on convenience or the researcher's judgment. Faster and easier than random sampling, but less precise and may not be fully representative of the population. Volunteer sampling. Participants volunteer to take part, often responding to advertisements or invitations. This method is easy to implement as it relies on people who are willing to participate, making it cost-effective and less time-consuming.
All in all, the 10 presenters will enlightening and beneficial discourse not only improve our learning knowledge but also clarified a deeper knowledge of good communication. By mastering different techniques and methods, we gain more confidence in our ability to express ideas clearly and engagingly. The main lesson from this course highlights the significance of knowing the audience, creating an engaging message, and effectively using visual tools. These abilities are essential regardless of whether we are delivering a presentation in a work environment or conveying information to colleges. Additionally, the cooperative atmosphere of 10 presenters has motivated us to share knowledge with each other by engaging in peer feedback and collaborative projects. We have acquired varied viewpoints and improved our presentation techniques. Education is an ongoing journey, and maintaining curiosity will assist us in staying at the forefront of our various domains. Let's take the insight gained from this course not into future pursuit, always looking for chances to grow and develop. I appreciate your commitment and effort during this course. Your dedication to excellence has been motivating, and I eagerly anticipate the remarkable things you will accomplish ahead.